We are finishing up lesson 2.1 part 1, and as we finish up we just have this linear correlation section to talk about. Basically we're looking at scatter plots, okay? That's the basics, but we're going to go into, okay, how do we write the line that goes through the scatter plot, okay? We can do it by hand, but with our lovely TI-84s we can do it by calculator also, so that's going to be part of this problem. So when we graph tables of data using our stat plots, we can tell whether or not the dots are clustered along a line. If they are, we say there's a linear correlation. So think scatter plots from back whenever you learned scatter plots, right? If the line has a positive slope, then we say it's a positive linear correlation. So if they're going up and to the right. If the line has negative slope, then there's a negative linear correlation. So if they're going down as you move to the right. It is also possible for graphs to have little to no correlation or weak or none. Okay. Now, there's some basic pictures. These are just pictures from the book here, but a positive correlation is moving up to the right. Here they give an example of a strong positive correlation versus a weak positive correlation. It's just a matter of how tightly clustered are the points. The tighter they're clustered around that line, the more of a strong correlation it is, okay? Same thing with negative over here at the right. You've got a negative correlation. Again, strong versus weak. How much do they make a line? And in the middle, you see what we usually call no correlation, little to no linear correlation. I am most worried about positive, negative, or no correlation, okay? You may see in the book they may talk about strong versus weak, but I'm most worried about positive, negative, or none. Okay. Now, okay, with this example, we have a table of values. It says we're given a table of weekly sales data based on market research for prices of boxes of a certain breakfast cereal and the number of boxes sold. Describe the strength and direction of the linear correlation. So that's going to be like positive, negative, or no correlation. Then write a linear model for the demand as a function of the price of the box. So we'll be writing the equation. And then we're going to use that equation or model to predict weekly cereal sales if the price dropped to $2 or raised to $4 a box. Okay? So, let's start by putting these numbers in your calculators.
Can't figure out, I got a minute, but can't figure out how to get the graph to show up.
Okay, so I usually take you guys into stat. I think you could go into the second list also. Into stat or list. I usually take you guys into stat and have you go number 1, edit, and hit enter. Now, I still have values in from whatever we last did. Your options. You can delete individual numbers or you can clear the column out. I like to go up to my header column and do clear, not delete, or you'll delete your column altogether, clear enter. And that will delete all my numbers. Okay? Go ahead and start typing your numbers in. I'm going to put price per box into L1, and I'm going to put boxes sold into L2. Oh, like where the calculator would have been helpful if you could remember? Yeah, interesting. I didn't realize they'd have anything like that on the...
I don't think I think I got a question about correlation, but I already had the graph on it, so it's pretty easy.
So I had to like figure out the graph. Maybe today's just probably more.
Look, is PSAT one of those tests where it goes, the questions adjust to correctness?
The PSAT felt a lot easier than it did last year, and I don't know if that means I did terrible or if I did great.
I thought that English was like ours.
But the English, I was pleased with the English because the biggest thing was like a paragraph.
Yeah, it wasn't that much.
Like there was no like 18 paragraph stories that you got to answer 6 questions about. Like those are terrible.
Okay, guys, you got your values in?
Yeah. So how you getting show up?
Hold on, I'm making sure I have my values typed in right, because if you type a number wrong, it is going to adjust the problem. Okay. You guys good? First of all, one thing we have to do is we have to turn on our stat plot. Okay, so I'm going to go into my y equals screen. I'm going to clear out anything I have here just so it doesn't get in the way, or you can turn it off. And then one way to turn on your stat plots is you just go up here to plot 1. If you've used your traditional L1 and L2, you can just turn on plot 1 here by hitting enter. Okay? And now, when I go to graph, I have a nice blank graph. Why do I have a nice blank graph? Right, but I turned on my stat plot, so I should be seeing the points. Why am I not seeing the points? Yeah, I'm on a 10 by 10 screen, and I'm supposed to be in the thousands. Now, I have a note to myself here. Let me check this out. I have a note to use Zoom and Zoom Stat. Let me see what Zoom Stat does. Oh, nice. In your Zoom menu, go to Zoom Stat. I'll be honest, I'm not 100% sure of what Zoom Stat does, but it was beautiful here, isn't it? So Zoom Stat must kind of adjust your window settings to whatever your numbers are in your list. Does that make sense? I like it because, so if I look at window, what did it do? Change my X-min and max to 2.28 and 3.72, which is above and below. And most importantly, it changed my Y-min and Y-max to numbers above and below. Okay, so does everyone have the points on their graph now? Okay. Now, first of all, we can answer the first question, which was describe the strength and direction of the linear correlation. What would you say about that? What'd you say? Strong negative? Definitely going in a negative correlation or in a negative direction because it has negative slope. And I would say it's pretty strong. So for that answer, I'm going to say strong, negative. Now, I will tell you guys, I have a lot to write in this little area, so beware. I told you a little too late. Sorry. Okay. So that's the first question. Describe the strength and direction. Now it asks us to write a linear model as a demand of the function of the price of the box. So, well, it is find the slope and y-intercept, but here's the deal. We're not going to do it. The calculator's going to do it for us. Okay? So
how are you going to have to write along?
Huh?
How are you going to have to write along?
Okay, so in order to do this, I'm going to go into Stat. So I'm going to go back to my Stat menu. And I'm going to arrow 1 over to Calc. And you're in a menu that looks like this. So we're going to Stat and Calc. And then if you go down to number 4, linear regression, because that's what we're doing. We're writing a linear regression. And we're looking for it to be in the form AX plus B. Do not pick number 8. It reverses things. Not exactly sure the reasoning and all that. But linear regression. And we're going to go into number 4. Now, here you're just picking what values do you want to use. My X's went into L1, my Y's went into L2, so this generic is set up. You could change L1 and L2 if you had different values, if you were using a different column, right? And I'm just going to arrow down. I don't need anything with the other two. I'm just going to arrow down to where calculate's highlighted, and I'm going to hit enter. It does its little thing. And it tells me y equals ax plus b is a form. It gives me a, which is a slope of negative 15,000 some. And it gives me b, which is a y-intercept of 73,000 some. Are your numbers different?
Me and Timmy's are.
I have 15,358.
My B's.
Okay, so here's the deal. My numbers are different from my answer key.
I think you typed something.
Okay, so here's the deal. Your answer should not match mine. Okay?
You got it like 7,300.
I'm going back
73,600.
and checking my numbers.
Yeah.
2.4, 2.6, 2.8, 3, 3.2, 3.4, 3.6, 38, 320, 33, 7, 10.
25, 5, or
26,
It's
25, 530 instead of 230.
Thank you. 25, 530.
And then 18,260
Oh my
minus
gosh.
620.
18,260. Okay.
I think that's right.
So now I'm going to go back. I'm going to do a zoom stat again, which is number 9. And I'm going to go back into my stat. I'm going to calculate. Whoops, I hit the, dang it. Okay, redo. Stat. Over to calc. Down to number 4. I'm going to go down to calculate.
That's right.
Yeah.
Now my numbers match your numbers. Okay.
It's
So,
okay. It's okay.
There's what happens when you type 1, or in my case, 2 wrong numbers. My numbers were pretty close to yours, really, weren't they?
Yeah.
But slightly different.
Oh,
okay.
in terms of table.
So, be careful there. Okay, so I'm going to write down some information here. So, we're being asked to write a linear model here. So, my linear model is the equation y equals, and my slope ended up being negative 15,358.92857x. You can round it to 2 decimal places if you want. Plus 73,622.5. Okay. If you want to shorten it up a little bit, the y equals negative 15,358.93x plus 73,622.5. This is my model. And here was the nice part, folks. My calculator did the work for me, didn't it? Okay. So, real quick, how do we do that? Because you're not going to remember come homework time how you did that, are you? Okay, so first of all, I went into stat. And when I was in stat, I went over to calc. Once I was in calc, I went to number 4, which was linear regression. That's what it's called. AX plus B. And then once I did that, I went down to, once everything was set up right, I hit calculate. Okay, so there are just some steps. I don't know, you might want to put something in your notes, or however you want to write your steps so you remember what to do on the calculator, right? Because we all know, otherwise we're not going to remember. I had to rely on my notes to remember from last year. Oh, I'm also going to write a note. What was the nice little Zoom feature we used? It was Zoom Stat, and that saved us a lot of time, really. So definitely remember Zoom Stat. Tell myself I need to remember it as well. Okay. Are we good there? We officially have one other piece of this problem, don't we?
Yeah. You just plug 2 and 4 in for X.
Okay. Now, there's a couple of different ways we can do this. I agree with what Logan said. Plug 2 and 4 in, right? Because it asks us, use the model to predict weekly cereal sales. Okay, I'm going to change colors here. So use the model to predict weekly cereal sales if the prices drop to $2 or raise to $4. 100% agree. The short of it is plug 2 and 4 in. Now, options here. Let's see. So if I write this out, what are we basically doing? Y equals negative 15,358.93 times 2 plus 73,622.5, right? You can type that into the calculator. That is perfectly fine. However, one thing that I forgot to do up here, my graph has the points when I look at it, right? If we go into y equals and we type this equation in, This will help us check for accuracy. Negative 15,358.93x plus 73,622.5. If I graph that, notice it goes through my dots pretty well, doesn't it? Okay. So, one option, I know what you guys were already doing, you just typed it out on the calculator, right? Another option, if you want, remember how we could use trace, and you could type in a value, an x value, and it'll give you the y value? You could do that here. So I could type trace. Now, notice right now, when I hit trace, it puts me on the line plot. I don't want to be on the line plot, so I'm going to arrow, I think it's up and down. Now notice when I arrow up and down, it puts me on y1. And now that I'm on y1, I can click trace and type 2. Okay, that didn't work. Oh, I was already on trace. Dang it. Trace, arrow down to get to the line, and then if I hit 2, it tells me x equals 2. When I hit enter, I'm struggling. Okay. So maybe I just need to give that idea up because it's not working. Because 2 is off the edge of the window. I thought I'd used that in the past. But it's not working for me. Unless yeah, it's not working. So just plug the 2 in. That's easiest, right? Now I will say, okay, did you guys already plug in 2, I assume? Negative 15,358.93 times 2 plus 73,622.5. Does your answer match my answer? 42,904.64.
Yeah.
Or if we round that to a nice, neat whole number, what is that approximately?
42,900.
Yeah. Or my answer key even just says 42,900. So, 42,905, 42,000. It's a big number, so they're ballparking it. So we got 42,904.64, or approximately 42,900 boxes. Okay, that was when x equals 2. What else do we have to do? X equals 4. Now, were you guys smart on your calculators? Remember, can you arrow up? Highlight that piece right up there. Copy it down there where I hit enter and just arrow over and change the 2 to a 4. Okay, that's an option there as well. When you plugged in 4, did you get my answer? $12,186.78, which in the book they rounded to 12,190 boxes. As long as you're in that area, it's good. Okay, 12,187 boxes. Okay. Questions there? Do we figure everything out? Okay. On your homework, on page 163, you're doing 2 through 12 evens, 45 to 48 old, 53, 68, and 82. 2 little comments. You'll notice up on the screen. Off to the side, what does it say? On 7 through 12, no graphs. I'm flipping to it now to remember exactly what the directions say, but the directions ask you to do something about graphing, and I'm not asking you to do that. It says write an equation for the linear function f satisfying the given conditions, and then it asks you to graph. Don't worry about the graph. Just write the equation on 7 through 12. Okay? And then there's one of these. Okay, 82. Beware, 82, folks. I don't know if I'm going to give full homework credit if you don't actually go through and attempt 82. 82 has A through I parts. And they're all doing average rate of change, though. Okay? It's just average rate of change on every single one of them. So just kind of beware. That's not just do one part and quit. Okay? Other than that, you guys have work time.